Okay, here's a problem from 1988 under the category exponents and radicals. Find the values of x and y so that 25 times 2 to the x plus 1 equals 16y, and 2 times 5 to the x minus 1 equals 5y. So let's isolate y in both of these equations. And in the second equation, and that means that this has to be true. And in order to make this easier to see, we can replace 16 with 2 to the 4th and 25 with 5 squared. So to make this equation easier to deal with, we can multiply both sides by a certain fraction. And now we can write it as this. Because of fractions of terms canceling out. And you can just subtract exponents, so you get 2 to the x minus 4 equals 5 to the x minus 4. And intuitively, the only solution to this would be x minus 4 equals 0 and x equals 4. Because when x minus 4 equals 0, that's 2 to the 0 equals 5 to the 0, and 1 equals 1, which is definitely true. But to prove this, all we have to do is that divide both sides by 2 to the x minus 4. And that would give you 1 equals 5 over 2 whole raised to the power x minus 4. And now it's obvious to see that the only way for this to be true is x minus 4 equals 0 and x equals 4. So now we got our value for x, and there's only 1. And now we can use that in one of the equations that we had to find the value for y. So using the first equation, 25 times 2 to the x plus 1 equals 16y. Substitute in x equals 4. And this gives you y equals 50. And in the second equation, just to check that we have the right value for y, we plug in y in the second equation. I meant x into the second equation. And that gives you again y equals 50. So our solution set is x equals 4, and the corresponding value of y is 50. So that's the answer to this problem.